All right, let's jump right in. We're going to talk about the fascinating intersection of quantum computing and the global energy sector. And this isn't science fiction anymore. We're talking about a technology that is moving out of the lab and into the real world. And it has this huge potential to completely reshape how we power our lives. So here's a question for you. What's the one thing that connects an electric car, the massive power grid it plugs into, and, get this, the security of an entire nation? Believe it or not, the answer is quantum computing. And in this explainer, we're going to break down exactly how it's becoming such a critical piece of our energy future. Okay, before we dive deep into energy, let's zoom out for a second and see where quantum is making waves across all kinds of industries. Understanding the bigger picture really helps us see why the energy sector is just such a perfect fit. So, globally, organizations are betting big on quantum to solve two massive challenges. First, there's untangling these incredibly complex optimization problems. Think of it like trying to find the one single best path out of trillions of possibilities. And second, it's about supercharging machine learning to find patterns in data that are just totally invisible to the computers we have today. And look, this isn't just theory. If you want to see how seriously other fields are taking this, just look at biopharma. A whopping 86% of them are already using quantum for optimization, for things like designing new drugs. That's a huge sign of its real-world value right now. So, okay, if pharma and finance are the ones jumping in early, you might be asking, where does energy fit into all this? Well, it turns out that the crazy complexity of our power grids makes the energy sector one of the most critical and promising places to test out this technology. First up, it's all about efficiency, right down at the local level. Quantum algorithms are being used to figure out the absolute best way for batteries to charge and discharge. This extends their lifespan and makes local microgrids a whole lot smarter and more resilient. But it doesn't stop there. Let's scale that idea up to the entire country. That same incredible optimization power can be used to balance the load across our power grids, which helps prevent blackouts and lets utilities plan for the future way more effectively. This is also a huge deal for our switch to green energy. One of the biggest challenges with solar and wind is that they're not always on. The sun isn't always shining, the wind isn't always blowing. Quantum can help manage that variability, making the grid way more stable as we rely more and more on renewables. And this next one, this might just be the most important piece of the entire puzzle: security. Our energy grid is a massive target for cyber attacks. So quantum isn't just a tool for optimization. It's becoming a necessary shield to harden our most critical infrastructure against the threats of tomorrow. And that leads us right into this crucial concept: post-quantum cryptography, or PQC. This is the key to that shield. PQC is all about creating brand new encryption that can stand up to attacks from both today's computers and tomorrow's quantum computers. It's how we build a truly future-proof, secure grid. And like I said, this isn't just stuff on a whiteboard anymore. This is really happening. Let's take a look at some actual, real-world examples where quantum is being put to the test as we speak. All over the world, we're seeing these really smart, high-impact partnerships pop up. So in France, you've got Pascal and the energy giant EDF using quantum to forecast EV charging demand. Over in Spain, they're optimizing battery deployment. And then in Canada and South Korea, the focus is squarely on security, building quantum-safe grids for everything from smart meters all the way to nuclear power plants. Each one is tackling a different, vital piece of the puzzle. And get this, these pilots are delivering actual, measurable results. For example, an Israeli company called Quantumize used a quantum approach to manage microgrids and achieved a 40% reduction in battery charging cycles. A 40% reduction! That's a massive efficiency gain that saves money and makes batteries last longer. So, if we pull the lens back out again, you can see this global race is really taking shape. But what's so fascinating is that it's not some chaotic free-for-all. Different countries are strategically carving out their own unique specialties based on their strengths. So instead of everybody trying to do everything all at once, we're seeing these distinct regional focuses emerge. For instance, Israel is really leading the pack with commercial microgrid prototypes. Europe is concentrating on renewables and peer-to-peer energy trading.
And here in North America, the big priority is infrastructure resilience and cybersecurity. And that diversity is really the key thing to understand here. This isn't a winner-take-all race where one country is going to dominate everything. It's more of a multifaceted global effort to innovate across the entire energy sector.
So with all this momentum, where is this all headed? Let's look at the road ahead, because things are starting to move, and they're moving fast. Right now, we are firmly in that pilot stage, but you can see a really clear and rapid shift happening. The next phase is strategic integration, where these solutions that we know work start getting woven into the very fabric of our energy systems. And the timeline? We're talking about full-on operational deployment within the next 3 to 5 years. That is right around the corner.
Which leaves us with one final big question to think about. This transition is no longer a question of if it's going to happen, but when and who. As this incredibly powerful technology starts to reshape our world, the race to secure and optimize our energy future is well and truly on.